Hey everyone, I'm Mick Sass, Senior Inspector for the RV Industry Association. Today we have a brief review of the changes to the ANSI A119.5 for this code cycle. As of September 1st of this year, 2020, these changes will be in effect. Our inspection staff will be citing these changes as advisory deviations in the comment section of the inspection reports, and this will go through the end of the year. On January 1st of 2021, all the changes to the 1195 will be enforced and cited accordingly. So let's get started with propane systems as they will pertain to park model RVs. We understand that the vast majority of park models utilize stationary gas supplies and do not rely on portable cylinders. However, if and when you do produce a model that requires portable cylinders, here's the change. When portable cylinders are installed by the park model manufacturer, the vehicle is allowed up to 4 removable cylinders. This is limited to 4 45-pound cylinders. This is a simple change to the language that allows manufacturers the option to utilize the current technology for providing owner's manuals to the client. Although not seen much anymore, printed owner's manuals sent to the client with a basket of individual manuals on all the components and appliances contained in an RV is still acceptable. Now, with the internet as accessible as it has ever been, providing the owner's manual online is the most current way to provide them. It can be done in the form of a PDF, a portable document file, which is simply downloaded to most devices, including smartphones. This or any other electronic method of acquiring the instruction manuals is acceptable. They can also provide this information in the form of a CD or a DVD. Most all new technology that is available and can provide this information to the RV owner is acceptable. This requirement is now in parallel with 2-9.1.2 for providing owner's manuals for all of the RV's appliances and components. Wall beds, or Murphy beds, have been introduced into the RV market, and with that in mind, a couple of considerations for their use. In general, a Murphy bed must be safely secured in both the stored position and in the deployed position. The latch or mechanism must be a positive securement that will retain the bed in both the stored position and the deployed position. Here we see two examples of a simple sliding bolt securement. Mechanical securements built into the folding mechanism are also acceptable. They must provide the bed with a secure stored position that will not unintentionally deploy. The mechanism must also provide a secure deployment position that will not retract or fold up when people are using the bed. So when the bed is deployed, it must be able to maintain that position when people are positioned on any section of the bed. As seen in the previous slides, latches or mechanical securements may be employed to maintain this open position. This is most important when people prop themselves up near the headboard to watch TV. Too much weight distributed to this area may inadvertently fold the bed into the stored position. So physical securement through sliding bolts as seen in the previous slide, or mechanical securements integral to the folding mechanism, the open position must be maintained. Additionally, if the design of the Murphy bed is such that the securement latch or bolt or other mechanism is not necessary to maintain the position, then that configuration must pass one test to be considered acceptable. Let's assume that the two center points seen here in red are the pivot points for the bed to fold back into the stored position. So from the center line of the pivot points to the headboard needs to be tested for the amount of weight it can support before it folds back down in the stored position by itself. So to do this test, the area needs to be able to support 500 pounds of weight evenly distributed between the pivot points and the headboard without the foot of the bed rising off of the floor. As usual, this can be documented by engineering analysis or by physical testing. A copy of a letter should be on file from the RV manufacturer or the bed manufacturer stating that these requirements are met and will also be acceptable when asked for by an RVIA inspector. Okay, the next change seems to be pretty much common sense. This is simply a clarification to assure that the potable water tanks filled through a city water fill are properly vented. It simply states that tanks that can be filled with city water connection must have a vent with piping and fittings of equal or larger size than the inside diameter of the filler pipe. So say the city water connection, seen here on the right, is a 3/4 inch connection with equal size PEX tubing leading to the tank. So a 3/4 inch vent is required, and all the fittings and the PEX tubing will need to meet the minimum 3/4 inch non-restricted inside diameter to the exterior of the vehicle. Now, from my experience, there are not many park models being produced that are equipped with potable water tanks. However, if your company should opt to install one, the following must be considered. Obviously, as seen here in this photo, we don't want them becoming dislodged during travel or while on location due to inadequate support structure. So the potable water tanks need to be tested to see that they remain in place with a load equal to 2 times the tank's filled weight, and it is applied in all directions except for upward. Compliance can be documented with testing, through engineering analysis, or through self-certification by the RV manufacturer. This is a new requirement that also involves the manufacturer of the tanks. Potable water tanks in this case. The tank manufacturer must provide a statement in their installation instructions that the tank securement needs to meet the securement requirements of 4-6.5.4. As the RV manufacturer, it is your responsibility to assure that this statement is provided by the tank manufacturer. Also, as the RV manufacturer, you will also need to be able to provide proof that this statement is present in the tank manufacturer's installation instructions when asked by the RVIA inspection staff. Now, the same requirements are going to apply to wastewater holding tanks under 4-7.11.1. Again, in my experience, there are not many wastewater holding tanks installed in park models. Most manufacturers utilize a direct piping to the sewage system at the park they are located. So, wastewater holding tanks must remain in place when a load equal to 2 times the holding tank's filled weight is applied in all directions except for upward. Also, the tank manufacturer must provide in their installation instructions a statement requiring the holding tanks be secured in accordance with 4-7.11.1. Now, this is again an issue that needs to be considered if and when a blackwater holding tank is installed in a park model RV. Also remember that when a blackwater holding tank is installed, they must have a continuous vent through the roof under 4-7.11.3. Additionally, since holding tanks are certainly not the norm in park model RVs, it should also be noted that flush toilets are not allowed when connected to a body waste holding tank under 4-5.2.2. With that being said, If holding tanks are being installed, the following scenario must be considered. This situation comes into play when a plumbing system with fixtures at different floor elevations force a fixture drain to be lower than the flood level of the toilet, as seen here. For example, this can be seen in many travel trailers with exterior kitchens. The sink in many of those outdoor kitchens will drain into the black water holding tank because it is the closest and/or the only accessible holding tank for that fixture. This causes the fixture drain to be positioned very low on the plumbing system and in many cases below the flood level of the toilet, as illustrated here. Mechanical seal toilets are the only option when connected to a holding tank. Flush toilets are again not allowed. If the black water holding tank were to become overfilled because of the mechanical seal toilet, it could potentially flow up into the fixture drain and eventually past the P-trap and into the sink itself. So, the use of backwater valves is required if this plumbing configuration is used. Here we see two typical backwater valves used in RVs. They are generally manufactured in both 1.5 inch and 2 inch sizes. Here is a cutaway view of a backwater valve similar in design to the 1.5 inch and 2 inch models that we would use in park model RVs. You can see that the flapper valve is hinged on the upstream side of the valve. Water can only flow through the flapper valve in one direction because the flapper valve is hinged to only open in the correct direction of flow. Water backing up through a holding tank would be blocked at this point as the flapper would be forced shut by water flowing in the wrong direction. So, as seen here, the backwater valve would be installed in the fixture drain to stop an overfilled holding tank from entering the fixture trap and the fixture itself. So again, with the backwater valve installed as seen here in the trap arm of the fixture, backfilling water and solids would be stopped. Additionally, if any solids were deposited in the horizontal section of the trap arm, when water from the fixture, the tub or the shower in this case, were to flow again, it will flush those solids back into the holding tank. Okay, now we go to the roof and vent pipe extensions above the roof. Here we have a change only in the height above the roof line. The vent pipe used to be required to have a minimum of 2 inches above the finished roof line. That has now been reduced to only 1 inch. The extension of the vent pipes above the roofline has brought up this scenario where a vent pipe exits through the exterior wall of the park model, then extends the required 1 inch above the finished roofline. Now this is being done primarily to avoid cutting holes in the corrugated metal roofing. As long as the top of the vent pipe is a minimum of 1 inch above the roofline, it will be acceptable to have the vent pipe exit through the exterior wall as seen here. However, the vent cannot simply terminate through the side wall as seen here. This vent arrangement will need a vertical extension to get the vent opening the minimum 1 inch above the finished roofline. Now for a little physics lesson today. That is that water does not compress. Air, however, does compress and can cause problems when testing. Most importantly, it can cause explosions. A weak metal seam in a water heater could explosively rupture under air pressure. Not so under water pressure. So to avoid these problems, this test is done with the entire system filled with water. Again, water does not compress. So this test with water in the system is now going to be pressurized to 80 to 100 psi. Remember that now there is no longer the plus or minus 5 psi of the given pressures. The test is to be performed between 80 and 100 psi for 10 minutes and the results recorded. The next test option is a two-part process with air pressure only. Step 1 is to test the system at 80 to 100 psi with air while the water heater tank is isolated with bypass valves to avoid compressing a large volume of air in the tank. So this 10-minute water system test at 80 to 100 psi is only testing the piping and its associated joints. The water heater tank is bypassed and not being tested. This will be tested in the second part of this two-part process. With that step complete, the second step is to test the entire system, including the water heater tank, with an air pressure of only 30 to 35 psi for an additional 10 minutes. Here also, in the second portion of this test, there is a change again with the removal of the plus or minus 2 psi. The test should be between 30 and 35 psi for 10 minutes with the results being recorded. The next change to be discussed is an exception to 5-10. This exception provides for adjacent lofts where there is a clear opening between the two areas of at least 60 inches, 5 feet in width, and the full height from floor to ceiling as seen in this drawing. Here, a stairway appears to separate the two lofts, but the stairwell separating the two loft areas is open and protected by a guardrail meeting the requirements of 5-10.7. Because of this 5-foot clear span opening that extends from floor to ceiling, the two lofts can be considered as one. This would also be true if the two adjacent lofts were at slightly different elevations. With these adjacent loft arrangements, light and ventilation, exit and fire detection requirements may be combined because the lofts can be considered as one. And finally, in a more common arrangement where the loft areas are separated, such as at opposite ends of a park model, each loft area must comply with all the requirements on both ends for 5-10. This includes that light and ventilation must be correct for both, exit must be provided for both, and fire detection equipment must be provided for both. Now, one more item concerning guardrails and ladders under 5-10.7.1. This is a clarification that provides specific dimensions for the opening between guardrails to accommodate a ladder. Where space is provided for a ladder between guardrails, a maximum of 12 inches is allowable over the outside width of the ladder. Remember, guardrails must be permanent. They cannot be mounted on hinges or made easily removable. So, let's say that this ladder is the minimum size rung of 12 inches wide as seen here and as required by 5-10.5.1. If the vertical legs of the ladder are each 1 inch thick, that makes the overall width of the ladder 14 inches. So the maximum width of the guardrail opening will be 26 inches. This maximum width allows the ladder to be placed anywhere within that opening. The ladder could be centered with 6 inches on either side. It may be placed with much more on one side as seen here with 10 inches to the left, or 8 inches to one side or the other, but still limited to a maximum opening on either side of the ladder of 12 inches or less. Okay, our last item for the day is on plastic composite decking materials. That's under 5-11.2.4. It now states that all plastic composite materials for exterior decks, stair treads, guards, handrails must comply with the requirements of ASTM D7032, which is the standard specification for establishing performance ratings for wood plastic composite and plastic lumber deck boards, stair treads, guards, and handrails. With this in mind, assure that the composite decking materials being used at your production facility are meeting these requirements. And as always, be able to provide evidence of meeting these requirements when asked by a visiting RVIA inspector. Thanks for attending this brief review of the code changes to the 2020 edition of the ANSI A119.5 Park Model Standard. Please feel free to contact RVIA with any questions concerning this information or any other code-related items.